Let's now talk about multiplying radical expressions. We did some simple multiplying earlier on where we just had one term multiplied by one term. Now we're going to look at one term multiplied by two terms, or two terms times two terms, expanding that discussion on multiplying. Here for radical expressions, multiplying is very much like multiplying polynomials. We distribute, we simplify. In the first example, root 3 times 2 root 3 plus 5, we would apply the distributive property of multiplication over addition in order to multiply these two radical expressions together. So root 3 times 2 root 3 plus root 3 times 5. We usually don't like the whole number or the coefficient to be on the right of the radical, so let's swap those around. And for the root 3 times 2 root 3, well, we can multiply the root 3's together, square root 3 times 3, but 3 times 3 is 9, the square root of 9 is 3. And keeping in mind that this is multiplication, so 2 times 3 gives us 6. 6 plus 5 root 3 would be our simplified answer. Looking at the next problem, we're multiplying two terms times two terms. We could do FOIL, first, outer, inner, last, because that will take care of all of the distribution we need to do for the multiplication problem. But I like using what's called the box method because it is more flexible and versatile for all different types of polynomials. I want to make sure that I'm multiplying correctly, so I prefer that method over FOIL. So I'll show you the box method. We create a box, and in that box, along the top, we have enough columns for one of our factors that we're multiplying together. So if I take the first one, 3 plus square root x, I'm going to keep the sign with the second terms. And then we have enough rows to accommodate the other factor, 5 minus root x. And with the box method, we multiply based on what the box has on the sides. So 3 times 5 is 15. 5 times square root x is 5 root x. And I'm going to put a plus there because we're going to add what's inside the box. 3 times negative root x, negative 3 root x. And then negative root x times positive root x is going to be negative root x times root x, which we can simplify. I'm going to bring it over here. Negative root x times root x, negative x times x. We get x squared, and when the x squared and the square root get together, they cancel, and we're left with just a negative x. So I'm going to replace what was in there with minus x. And now, once we do the multiplying with the box, we take everything inside the box and write it out in a string. 15 plus 5 root x minus 3 root x minus x. So everything up here gets written below. And if we have like terms to combine, we will do that. And we do indeed have like radicals that we can combine. 5 root x minus 3 root x. We can say 5 apples minus 3 apples is 2 apples. 15 plus 2 root x minus x. We'll just bring the 15 and the minus x down. We have nothing else that are like in terms of terms or radicals or numbers. And so that's our final answer. Looking at a similar one, I would like for you to pause the video, try this one on your own, and then when you resume, I'm going to work through it with you so that you can check your work. We'll create another box just like before. 5 plus root x, 5 minus root x. I will point out that it does not matter which factor goes on the side and which factor goes across. When we multiply, the order does not matter. So same with the box. It doesn't matter which order we put it on the box, as long as we make sure this is one factor and this is the other factor. And then we multiply. 5 times 5 is 25. 5 times square root x is 5 square root x, and I'm going to keep that plus sign in the front. It also helps to remind me that I'm adding at the end and not multiplying. 5 times negative root x, negative 5 root x, and then square root x times negative square root x, square root x times negative square root x. We just did that in the previous problem. That's minus x. Now we write it out. 25 plus 5 root x minus 5 root x minus x. And we have like radicals in the middle. But 5 root x minus 5 root x, that'll be 0. So we're left with 25 minus x. These two factors are special. We've seen something similar to this before when we talked about factoring special products, particularly factoring the difference of squares. Notice that we have the same term in the beginning, 5 and 5, and in the second term in both of these factors, they're almost exactly the same except for the sign. One's positive and one's negative. They actually have a name in that they are called conjugates. I bring this up because we actually need conjugates when we talk about dividing these radical expressions. What do you notice when you multiply conjugates together? What happens in the final result? Can you see something interesting that happens? Well, with the middle terms canceling each other out, we are left with a polynomial, not a radical expression. The roots are gone. And this is actually a good thing when we get to the division part.